We need to find critical points of f, and we need to apply the first and the second derivative test. So let's do that. F equal to this one. You need to find critical points. So this function is differentiable. So to find critical points, we find C such that f prime at C is 0. So f prime of x 8 x7 x minus 4 power 7 plus x8 7 x minus 4 power 6 times 1. I apply the product rule and the chain rule. This one, we can group x power 7 and x minus 4 power 6 outside. So to do that, 8 x power 7 x minus 4 power 6, left over is x minus 4 for the first term. Second term, x7 x minus 4 power 6, what's left over is 7 x. So let's group that. Group this term. X power 7 x minus 4 power 6 inside 8 times x minus 4, 7x. x7 x minus 4 power 6, 8x, 32, 7x. So we have 15x minus 32. Now this is f prime of x. So f prime equal to 0. Give us x is 0, x is 4, or x is 32 over 15. These are three critical points. The critical point of f are 0, 4, 32 over 15. Now let's do the first derivative test. We have x critical points 0, 32 over 15, 4. My order is increasing. f prime of x is this product. So we can write down three terms here separately. x7 x power 7 x minus 4 power 6 x minus 4 power 6, and the last one 15x minus 32. We know that 0 here, 0 here, 0 here. Make the derivatives 0, 0, 0 at a 3 point. Now x power 7, so it's going to be negative before 0, positive after this. For the second one, negative, negative, positive, and so positive here. Power 6 only non-negative. F prime, so this is positive, negative, positive, positive. You multiply on this side, negative here, so give negative. So this one gives us f of x is increasing on this interval, decreasing, increasing, increasing. So this tells us that at this point the function has local max. F takes a local max at x equal to 0. At x equal to 0, yeah. F has a local mean at x equal to 32 over 15. F takes local mean at x equal to 32 over 15. And the point 4 is not in local max, not a local mean. At x equal to 4, we don't have local max and local mean. Neither local max nor local mean, because this is keep increasing there. So that is the first derivative tables. Now let's do it for the second derivative test. Second derivative test. The second derivative test says that f double prime is continuous on an open interval. F prime at C is 0 if F prime at C, F double prime at C is positive. So this means that F C is this point. At that point, F prime at C is 0, so it's horizontal here. But F double prime is positive. This means F prime at C is increasing at C. So this is 0 at this point. Before that, it is negative. After that, it is positive. So the function, we should expect to have a local mean here. F has a local mean at C. That the second derivative test tells us. That is the first case. The second case, if f double prime C negative, so f double prime is negative, so f prime is decreasing. It is 0 and now decreasing. So before that is positive, after that is negative. So we should expect this local max. F has a local max at C. And the last one, if F double prime C 0, we cannot say anything. Inconclusive. So let's do that. F double prime. We need to compute F double prime. F prime is here. F double prime of x equal to 7. So that's a lot to do derivative. 7x 6 multiplies on this plus x7 multiplies the derivative of this. Now we continue to do product rule. This one is good. Second terms, x7 multiplies 6x minus 4 to the fifth, 15x minus 32 plus x minus 4, 6 multiply 15. This is F double prime. We can group that. This one keep the same. Second one, x7 outside. These terms in common. So we can group x minus 4 power 5 here. Inside we have 6 times 15x minus 32 plus x minus 4 times 15. That is the second terms. Now you see that we have x minus 4 here in common. Group that. And x power 6 also in common. X power 6, x minus 4 power 5. Inside we have 7. X minus 4, 15x 32. X 6, 15x 32, 15 x minus 4. Now you need to compute F double prime and see whether it's positive or negative. We have 3 critical points: 0, 0, 32 over 15. So F prime x, 0 here, 0 here, 0 here. F double prime at x when x equal to 0. This one is 0. So it's inconclusive. The second derivative test cannot say anything here. At 32 over 15. So we know that 32 over 15. This one is 2 times 16 over 15. 16 over 15 bigger than 1. So this is a bit bigger than 2. 2 point something. So this is less than 4. These terms negative here. You need to plug in to compute here. 32 over 15, this one is 0. This one is 0. The only non-zero term is here. This one negative, negative times at this point positive. So this is negative, negative, negative. So positive, positive, positive. This is positive here. I hope you understand that. These two terms are 0 at this point. Because you plug in there, you see 0 here, plus 0 here. So the sign depends on the sign of this term. X multiplies this. X, this point positive, but this one is negative. Negative times negative, so positive. About x equal to 4. X equal to 4. This is 0. So the whole thing is 0. Again, second derivative test is inconclusive. Second derivative test inconclusive at x equal to 0, and it's also inconclusive at this point at x equal to 4. But at least the second derivative test can tell us the behavior here. F double prime positive, so it's increasing. So F prime is increasing, is negative 0 positive. Let's go like this. So the figure we should expect the graph decreasing, then increasing. We should have this local mean at 32/15. So F has a local mean at 32/15. That is the only thing the second derivative can say. So first derivative test tells us more.